How's it going, guys? So today I'm just doing a quick video discussing ransomware and what makes it so absolutely dangerous. For those of you who don't know, ransomware is a form of malware that encrypts certain files on either a network or a drive and then demands money sent to the hackers in order to decrypt all of the encrypted files. So it's been very popular lately in the news, especially here in Florida. Over the past 3 to 4 weeks, there's been, I believe, $1.1 million paid out to hackers caused by ransomware hacks. The biggest problem with ransomware is that, unlike other malware such as rats or keyloggers, which can be stopped by simply disconnecting from the internet, once a ransomware has had its effect, or rather it's encrypted all of the files it was meant to encrypt, there's nothing you can do from that point forward to recover the files aside from either paying the hackers the sum of money that they requested or being lucky enough to have had a backup and able to put the files back to their original state. The other big issue with ransomware is that for having such devastating results, it's actually incredibly easy to create. In an attempt to not only demonstrate how ransomware works and also demonstrate how easy it can be to create, I've put together a small directory of possibly important files. So for instance, this could be my homework that I have to turn in. That could be my dissertation. That could be anything. This could be a bank file showing how much money I've made and how I've made it, and it's very important to keep. Precious family photos, important computer specs, and things like that could all exist in a simple directory somewhere on your computer. And very briefly, or should I say very quickly, I will put together a ransomware application using nothing but found functions and extremely simple code in order to encrypt these in a similar manner to that of ransomware. So the first thing that we're going to do is open up a Visual Studio project. This is just a blank form, and we're going to be using as many public functions and pre-built functions as possible just to demonstrate how easy it can be to basically copy and paste together a very simple ransomware application. So the first thing I'm going to do is, I already have all these in a text file, but almost all of them can be found publicly, is we're going to copy and paste a raindoll encryption function and a raindoll decryption function. And essentially, these are what is going to be used to encrypt the files in those directories. These are totally public. You can find them pretty much anywhere. It's very simple to Google them. I found them in all sorts of different languages, along with other encryption algorithms like XOR or AES, things like that. And then in the load event, we're going to basically create a pre-built function that's already in, that's already provided, which is get files. So we're declaring a string array, and we're adding all of the files in this test directory here into this string array, and we're doing all of these subdirectories as well. So this will not only get what is in this test directory, but also get what's in the second directory. So then the next thing that we'll have to do is a simple for loop. And essentially all that we have to do is we're going to create a byte array. And this byte array is going to be file system read all bytes. So we're creating a string array of the paths to all the files, and then for each file in this string array, we're going through and we're creating a byte array, getting all of the bytes from the file. And then we are going to actually have to encrypt those, but we cannot encrypt them as bytes. So this is probably the only part that actually ever required too much thinking, at least in the original creation. So instead of just going for the bytes to be encrypted, we're going to have to convert the bytes to a string, get string bytes, because we're going to use the byte array. And then finally, we just need the encryption key, which in this case we'll just use test, I guess. And then all it's going to be after that is we're going to have to overwrite the current files. And we're going to have to convert this encrypted string back to bytes. And then, there we go. Okay, so essentially what we've done is we have created a string array, created a string array holding all of the strings to all of the files in our test directory. Now we're iterating through all of those files, and for each file we are getting the contents of the file into a byte array. We are converting the byte array into a string. We are encrypting it with the raindoll encryption function using the key test, and then we are overwriting all of the old files with the new encrypted string, and we're converting it back to bytes from the new encrypted string to the old files, essentially overwriting them. And that is it before we have to add any controls. Okay, so now we'll have to add some controls. So we'll basically just need a button to decrypt with and a text box for the key. I don't know why I'm actually worried about that at all. Okay. So what we want is that once somebody put in the correct passcode, it would be decrypted, where all the files that were encrypted are going to be decrypted. I'm sick today, so I apologize that I can't function. But it's going to be the same idea. We're going to be creating a new string array, and we're going to be adding all of those files to it. And then once again, we are going to iterate through each file. And so this time we are going to be decrypting files. So we'll use our raindoll decrypt function that we have, which, like I said, is public and easy to find. We're reading alt text from the file, and then we're going to be trying to decrypt it with the text box, whatever the text is in the text box, assuming that's the correct key. That should work just fine. And then all we need to do is overwrite what we had before. So now we are overwriting the infected files with our handy dandy decrypted files. Okay, and I do believe that that should do it. Yeah, that's all I had in my notes. So yeah, that should do it. So these two almost don't matter. The vast majority of the code is actually just the public encryption decryption keys. So realistically, it is essentially just overwriting all of the files with an encrypted version of their bytes that you pulled in the first part, or in the first place, and then once someone has the key, they can decrypt it, and the files will be overwritten with their original bytes. So what we can do is open up our test directory, and now that we have our test directory open, we can, well, I guess I should have seen that coming. So I guess let's start our ransomware little application. Okay, so this is now open. You might have just downloaded this off the internet or accidentally gotten it from a PDF or something like that, and you have no idea what it is. But sure enough, you go and look at your homework, and it no longer makes any sense, and that's super weird. What about my bank account? Uh-oh, they don't support the file format. Well, hopefully everything in here is safe. Here's the picture of my loved one. Uh-oh, and this is all my technical analysis. How am I supposed to know if my computer's on if ismycomputeron.com saved website unable to do so? I'll never know if my computer's on. So that is the general idea of encryption. And then if I think it was all caps. Let's try it. And if we refresh it, yay, we're back to normal. And if we go down, my family member is back, and so are my bank statements, thank goodness. And my homework, so I don't fail that class, is here again. So it looks like everything is back to normal. So now that we have a better understanding of how ransomware works and how easy it can be to create, there's just a few things to discuss now that you guys kind of hopefully have a better understanding of the back end. First of all, this would be horrible ransomware to actually try to use it for malicious purposes. There's actually a glaring flaw in this code, and I put it there purposefully, and a normal person would not be able to probably detect it, but then the moment that anybody with good technical abilities was involved, the ransomware or this ransomware would be destroyed almost immediately. And I will tell you, it has to do with that line right there. There's something about that line that will inevitably doom this, which, like I said, is very purposeful, and I did that because it's not a video about creating and using ransomware maliciously. It's just supposed to be a video trying to help everyone understand how it's working and how it's doing what it's doing. The other big issue that can come with ransomware, even with an understanding, is, again, it also has to do with this encryption line. So if I was a malicious hacker and I don't care about future transactions, or even if I do, I don't think it'll detect it. I can just create a gigantic random string on the fly to encrypt your files with. I could just literally create a random number between 1 and 15 billion and encrypt your files with the string version of that, which will mean that your files will never be decrypted. Even if you paid, there is never any guarantee that the person who encrypted all of your files will also be willing to decrypt them, or even has the ability to, because like I said, if they don't really care, they can encrypt them with whatever they want. And if it's something that nobody knows and it's just generated differently for every person, with no database keeping track of it or anything like that, then yeah, it can be a huge deal to pay and then still lose everything. And it does happen, unfortunately. I think 25% of, I saw some stats the other day. I think 25% of ransomware victims don't even get the files back, if I remember. But that's almost regardless. It's just something to always really think about. It's always very tempting to want to pay for the encryption key, or should I say the decryption key. But just because you do that, it's not a guarantee that the hacker is going to be willing or even capable of decrypting your files, and you're always going to be paying in Bitcoin. So once the Bitcoins have left your wallet, it is unfortunately all over. You won't see that money again. The other big issue is that it's very easy to add additional loads to the application. So it could be bound with a stub for either a rat or other malware, or even more ransomware, where you decrypt all your files, everything's looking great, and then 2 weeks later, even though you or none of your coworkers, nobody at City Hall has ran or downloaded any new files, they can, it might just be that they have dropped a package off somewhere on your hard drive, and it is just patiently waiting to be activated by any number of signals, whether it's just, it's meant to wait 2 weeks, or it can be called from a hacker's server or something like that. So it's extremely important that if you make the commitment to pay the hackers and have them decrypt all of your files, that you follow up with anti-malware and really do a good scrub of your computer to make sure that nothing like that is on there. If you have backups that are not safely put somewhere else on your computer or on a network, are not going to be safe. A backup can be encrypted just like any other file. So if you don't have like server hosting for any of your backups or anything, the one thing you can maybe try is putting your backups in like the System 32 folder or something like that, just somewhere that holds a lot of Windows objects and things like that, because obviously the ransomware cannot encrypt all of the Windows files that are running your machine, because if they did that, then your computer would just be bricked and they would never get their money, because you would probably never know what happened. But yeah, so the best route to take is just simple prevention and being extremely safe with where you put backups, how you back things up, and what kind of files you're downloading. Extension spoofers are still a thing. So if you have a attachment that doesn't seem like it makes a lot of sense in an email or something like that, or you're seeing a file that is like thanks.exe.txt, that's going to be a file spoofed extension. So that's actually going to be an executable file. And I can do a video on how extension spoofing works later. But it's just extremely important that you prevent ransomware from getting on your computer in the first place, because once it's on there, it is incredibly difficult to recover from without either paying out or starting over. So yeah, hopefully to at least some of you this was helpful, and this kind of dragged down at the end, and I didn't really mean for it to, but that just sometimes seems to happen. But if anyone has any questions, feel free to post comments. I'm not going to go into what the fatal flaw is, but I don't think if you're that curious, I don't think too much research would be required. But yeah, this is a extremely basic idea behind how ransomware works. And again, it was extremely easy to put together using two public functions and a built-in function. So realistically, I just had to write 2 for loops, and just by doing that, along with knowing the basics of file encryption, I was able to make a functional yet vulnerable ransomware application. Thanks.